Hey guys, this is Josh K here. We're going to be doing question 4 of the Math Olympiad that we were doing. Yeah, we've done questions 1, 2, and 5. Then we did question 6. Now we're on question 4. We've still got question 3 to do. There's a lot of controversy about that question. So let's get started. I mean, I remember I was tempted to look at the coordinates when trying to solve this question the first time. I realized that was not the correct path, and because I'd been so stuck up with that specific route of solving this equation, I then checked the mark scheme. I didn't look at the entire answer. I only looked at a little bit of it. One bit said to create a triangle like this, and then it said rotate it. I just closed the answer book and realized what it meant. I took this. I had drawn down this picture of the square before, and I realized these triangles I just rotated, and it's just this triangle. When I realized that, I could solve this without any help from the mark scheme. I did try this out by myself behind camera, and it worked. So I'm going to just go through my solution with you, and then I'm going to go through what the answer book actually says, because I haven't read that yet. So let's get started. So we know that there's a triangle, this triangle that I've drawn here, and we can rotate it 90 degrees to give us this triangle. And with that, we know that this height, Z, is equal to this height, which would be this length, P, plus Q. So you know that Z equals P plus Q. We also can do the same for this W. We know that this length is equal to this P plus this rotated Q, which is over here. So W is equal to P plus Q. Hang on, maybe we got our P plus Q already. Okay. Now let's find out what X is. So we know we can work out that X is this height. Rotated it, it's just basically this length P. So we know that X equals to P. And then we can see that this for this Y length, for this Y length, which is this bit, we can see that rotates to this length. So that's Q. So we know Y equals Q. Good. We got all the basic equations that we need to solve this problem. So suppose we had the equation. What we know that we want to find this equation, but what is the sum of W plus X plus Y plus Z? Let's not worry about the 3 for the timing. We can cancel this down. We can cancel it. Now we know that X is P and Y is Q, so we can cancel those bits down. So we know that this is equal W plus P plus Q plus Z. Okay, so we know that this is equivalent. So I'm just gonna. And let's do another enter. What else can we say about this equation? We know that W is equal to P plus Q. So let's command copy, paste it. We know that we can keep these P and Q's. So copy that, paste it, and we know Z is equal to P plus Q. So we can copy that, paste it. There we go. Yeah. So then we realize that this can factorize to P plus Q plus P plus Q plus P plus Q. You can factorize to 3P plus 3Q, which can then factorize to, it factorizes to, I'll do 3P plus 3Q, and obviously that factorizes even further to equal 3 P plus Q. That's simple. So we know that if we were to get this straight and on one line, this is equivalent to this. Divide both sides by 3, you get P plus Q equals W plus X plus Y plus Z, all divided by 3, guys, and that is our equation here. P plus Q equals all that divided by 3, and that's your proof. You know, this triangle here, and that took barely any time, guys. I mean, mainly because I tried to test this out in my own time after all that testing. So you remember, you can just cancel, this is a lot of substitution rather than cancellation. Just substitute the values in, and it just proved itself. And it's all because of this square, which you could use, and this triangle to work out this. So shall we go through what the answer booklet actually says? So, page 29. Okay, actual solution to question 4. So the vertices of a square, P, is all of these vertices over here. They're all positive. Proof, yep. The solution, if we rotated the right angle triangle, if we rotate the right angle triangle made by these coordinates about the center of the square, okay, I didn't talk about the center of the square, we form a new larger square, yep. Consisting of the original square and 4 congruent triangles, yep. From its construction, we know that the sides of the larger square, so it's saying that the sides have to be, of the larger square is p plus q, so then it then states that the top length and the other length be what? Let those two points that are not on the axes, they gave them names of V and W, and they then said they talked about the coordinates of them, and then they said adding the sum of the coordinates, you'd obtain p plus. They said they'd obtain this, which they simplified to this, and then they said adding the other coordinates, they'd obtain. I get what they're saying. They basically worked out the point of this is what they did. Instead of us doing, they said, okay, this coordinate is y, z, but its coordinate is also going to be p plus. No, it said it's also going to be q, and then p plus q, and then they said this one's going to be p plus q, p. So that was what they did, and then they said, oh, the sum of all these will be 3 plus pq, 3p plus q, and then they said, oh, the sum should also be the sum of these ones. So then they got to the equation here that we did, divided it, and they said this as required. Note, we do not know which of V and W is A and B and which is C and D, given the way that we have not. Oh, I see. Oh well. Yeah, because I think I did something a bit dodgy. I actually labeled these two beforehand, mainly because I was relying on the fact that they gave them in an anti-clockwise, counterclockwise order, but I didn't expect them to go this, and because they gave this coordinate before they gave this coordinate, you'd assume it was like this. Yeah, but they didn't do that. But guys, this is your solution to question 4. If you were wondering about it, just watch this actual solution. This is the solution that works. My makeshift solution's a bit dodgy. This question really got me out in the exam, mainly because I was just so hoping that we could use coordinate systems to solve this, but no, you'd have to use congruent triangles instead. So I hope you guys enjoyed this video, and in the next video we're gonna be doing question 3, my answer, the controversy behind it, and stuff. See ya.